Molarity. Molarity is the most common way to measure the concentration of a solution in chemistry. Molarity is the number of moles of solute in 1 liter of solution. The key words here are moles of solute. So remember that solute is the amount of usually solid substance that can be dissolved in a solution. And the other key words are in 1 liter of solution. So remember, the solution is not only, in typically the solution, the solvent, the thing that dissolves the solute, that is water. So the solution is typically made out of water and some sort of solute, which is a solid that is dissolved in water. So the key is that you're looking at the moles of solute, how many moles of solute you have in 1 liter of solution, which is a combination of the water and the solute together makes up 1 liter. So the definition for like a 1 molar solution would, if you had 1 mole of solute substance and you mix that in with water to make 1 liter of solution, that would give you a 1 molar solution. So that's the concentration of a solution. If you added double the amount of moles, so let's say you put 2 moles of solute in, and you mix that up, so it made 1 liter of solution, well then you'd have a 2 molar solution. So a 1 molar solution is abbreviated as 1 and then a big M for 1 molar. So just to be clear, if you wanted to make a 1 molar solution of salt water, first you would add 1 mole of NaCl, and then you would add water until the 1 liter mark on the graduated cylinder, or on, usually it's called a volumetric flask that you would be using. So your total amount of solution would be 1 liter of solution. So this is a 1 molar solution. Whereas there's also a thing called molality. If you're making a 1 molal solution, that way you'd take 1 mole of NaCl and then you'd add 1 complete liter of water. So your total amount of solution would be past the 1 liter mark. So we're going to focus on molarity, where your total amount of solution is 1 liter to make a 1 molar solution concentration. Obviously, in order to make this 1 molar solution of salt water, you'd mix the solute and the water together. So to make a 1 molar solution of NaCl, you'd have to figure out, okay, what is the molar mass of NaCl? So if you looked on the periodic table and you added up Na, which is about 23, and Cl, which is about 35, you get a total of 58 grams of NaCl per 1 mole of NaCl. 1 mole of NaCl would have 58 grams of NaCl roughly in it. So if you were making a 1 molar solution of NaCl, you'd mass out 58 grams of NaCl. You would add this to your volumetric flask or graduated cylinder, and then you would add water until the 1 liter mark, and this is all water in here, and then you'd mix the solute and the solvent together, and that would give you your 1 molar solution of NaCl. Whereas if you wanted to make a 1 molar solution of glucose, the chemical formula for glucose is C6H12O6. So you'd have to look at the periodic table, and carbon has roughly a mass of 12 grams per mole. You have 6 carbons. Hydrogen is roughly about 1 gram per mole. You have 12 hydrogens, sorry. And oxygen is roughly 16 grams per mole. So you'd have to multiply that by 6. If you add them all together, you'd find out the molar mass of glucose is 180 grams. So obviously, to make 1 molar solution of glucose, you'd add to, let's say in this case, a container, 180 grams of glucose, right? Well, obviously this is going to take up more space than when you made the salt solution when you only added 58 grams. You're going to add a lot more grams of glucose in this container, and then in order to get to the 1 liter mark of water, well, then you'd add just water to the liter mark in this area, and maybe you have less water when you made less water now when you're making the 1 molar solution of glucose versus when you made the 1 molar solution of NaCl. So the key points are, to make a 1 molar solution of NaCl, you'd take 58 grams of NaCl and add water, 58 grams, add water until the 1 liter mark to give you a total volume of 1 liter of solution. For glucose, you'd add 180 grams of glucose because that's 1 mole of glucose, so it would be more solute, and you'd add water. It would be less water in this case than the previous situation, and your total volume, though, would also be equal to 1 liter, and you'd add water up to the 1 liter mark. So different substances are going to have different molar masses. And so the key is for each substance you have to find the molar mass in order to figure out how many grams you're going to add to get a certain concentration of solution for molarity. So you need to figure out the molar mass of the substance, and this will determine the amount of solute that you'll add to your solution to make, in this case, a 1 molar solution. So when we made the 1 molar NaCl solution, you had to add one more water because you had less solute. Then when you had glucose, you had more solute. You'd had to add less water. But the final volume of each of the solutions when you made the 1 molar solution of each one was 1 liter of solution. So that's the same. The equation for molarity is the amount of solute in moles divided by the volume of solution in liters. So molarity, big M, is equal to the amount of solute in moles divided by the volume of solution in liters. So in order to make a 1 molar solution of NaCl, again, you'd take 1 mole of NaCl and you'd add water, so you'd get 1 liter of solution. 1 divided by 1 gives you a 1 molar solution. That's if you wanted to have a more concentrated solution of NaCl with more NaCl and less water. Well, you could add 2 moles of NaCl, and you could then fill up the container up to the half liter mark. And if you did that, 2 divided by 0.5, that would give you a 4 molar solution. So it would be 4 times as concentrated as the 1 molar solution. So a 4 molar solution would be considered like a concentrated solution, and a 1 molar solution in comparison to the 4 molar solution would be a dilute solution. Now we're going to try some practice problems. First we'll do an easy practice problem. It says if you want to make a 5 molar solution of hydrochloric acid and you want to make 3.5 liters of solution, how many moles of hydrochloric or HCl will be in the solution? Well, first of all, we have to take our equation. We know that molarity is equal to moles of solute divided by liters of solution. So if we fill in this equation, we can say, okay, well, I know that I want to make a 5 molar solution, so I'm going to put that on this left side. I know that I want to make 3.5 liters of solution, so I'm going to put that in the denominator on the right side. And how many moles of solution, or how many moles of, HCl do we need, moles of solute do we need? Well, that's our unknown, our moles of solute. So you can either write that as a question mark or you can write that as an X. That's what we're trying to solve for, moles of solute. So in order to solve for X, you probably want to first multiply each side by 3.5 liters and multiply this side by 3.5 liters, because then the 3.5 liters in the denominator and the 3.5 sorry, 3.5 liters on the other side. These will cancel. So if you multiply each side by 3.5 liters, you're left with 3.5 liters times 5 molar equals X moles. Well, what is this molarity? Molarity is just moles over liters, right? So we have 5, the unit is molarity or moles over liters, times 3.5 liters equals X moles. Well, the liters actually cancel, so yeah, you're just left with moles. When you multiply 3.5 times 5, it gives you 17.5 moles. And this is how many moles of HCl that you would need in order to make this 5 molar solution and to make 3.5 liters of it. Okay, this would be a medium type practice problem. A solution was prepared by dissolving 21.1 grams of sucrose to make 220 milliliters of aqueous solution. Find the molar concentration of this solution. We start out knowing that our equation is molarity equals moles of solute over liters of solution. And we're given, our known is 21.1 grams of sucrose. So we're not given moles of solute, so we need to find out moles of solute from this information. We also are given 220 milliliters of aqueous solution. Well, we need to convert that to liters because ultimately to use the equation you need liters. So in order to find out how many moles of sucrose we're dealing with, we need to use a conversion factor. So we know that if you add up the 12 carbons, the 22 hydrogens, and the 11 oxygens, I figured out that 1 mole of sucrose is equal to 342 grams of sucrose. So using this conversion factor, I can multiply what we know we have, 21.1 grams, and I can put 342 grams of sucrose on the bottom, and I know that is equal to 1 mole of sucrose on top. So if we do the calculations, 1 mole of 21.1 grams of sucrose is equal to 0.061659 moles of sucrose. Alright, and then in order to convert the 220 milliliters of aqueous solution that we want, we need to convert that to liters in order to use this equation. So you should know that for every 1 liter of solution, that's equal to 1,000 milliliters. So we're going to use that conversion factor. Milliliters cancel, and you're left with 0.220 liters of solution. Alright, now if we plug these numbers into the equation, we plug in 0.0616959 moles divided by 0.220 liters. That should give us our molarity. So after taking 0.0616959 moles, dividing it by 0.220 liters, the molarity is 0.28 molar. That's the molarity of the sucrose solution that we just made. I ran out of time to explain this more difficult practice problem, but if you want to try it using stoichiometry and all of your knowledge of molarity and previous knowledge of limiting reactants and limiting reagents that we've studied this year, feel free to try it. That's the end of my molarity video. I hope you enjoyed it and learned a lot. Thanks.